So whenever we have to subnet a network, in our example we have a network address 211.235.0/24. We have to rob Peter to pay Paul, so to speak, meaning we have to take some of the host bits. Right now we have 8 host bits, and use them as network bits. Yet on the other hand, we have to consider how many host bits we must keep so that we can accommodate the requirements for the locations and for the connections. In our example, we need 75 hosts here in network A, 45 hosts in network B, 18 hosts in network C, and then 2 hosts each for networks D, E, and F. Now, for each of the subnets that we will create, we will specify the network address, an address we cannot assign to a machine. The first and last unicast addresses. Unicast addresses can be assigned to computers, routers, switches, printers, and so forth. And then, of course, the broadcast addresses, again, an address that we cannot assign to a machine. With that said, we now apply our hosts formula, which states the number of hosts is 2 raised to the number of host bits minus 2. Minus 2 is the broadcast and network addresses that must be subtracted. So when we apply this formula, we will find out that for network A, we need to keep 7 host bits so that we can accommodate the requirement of 75 hosts. For network B, we need to keep 6 host bits so that we can satisfy the requirement of 45 hosts. For network C, we must keep 5 host bits so that we can accommodate the requirement of 18 hosts. And then for the network connections, the connecting networks, D, E, and F, we need to keep at least 2 host bits, which will give us each 2 unicast addresses so that we can actually connect these networks. We will note now that we have 25 network bits remaining for network A, 26 network bits remaining for network B, 27 network bits remaining for network C, and 30 network bits for networks D, E, and F. There are 32 bits in an IPv4 address. Since we use 7 host bits, we subtract that from 32, and that gives us then 25 network bits. And of course for network B, we have 6 host bits, we subtract that from 32, which gives us 26 network bits, and so forth. Now if we apply this now to our task, we have network A with 7 host bits, 25 network bits, a subnet mask of /25, indicating our last network bit is bit number 25. We know that bit number 25 is in the 4th byte and it's worth 128. For network B with 6 host bits and 26 network bits, a subnet mask of /28, we know that bit number 28 is worth 64 and it's in the 4th byte. For network C, 5 host bits, 27 network bits, a subnet mask of /27, we know that bit number 27 is in the 4th byte and it's worth 32. For networks D, E, and F, each we have 2 host bits, 30 network bits, a subnet mask of /30, and bit 30 is in the 4th byte and it's worth 4. We will now apply all this pre-work to our task at hand. Now network A, we will maintain the original network address, 211.235.0, but we will change the subnet mask from /24 to /25. Now bit 25 is in the 4th byte, it's worth 128, so we have to add this number 128 to the 4th byte to get to the next network. Therefore, network B's network address will be 211.235.128. Network A has a total of 126 unicast addresses. The address immediately prior to the next network, 211.235.127, is the broadcast address for network A. Network B, we have added 128 to the 4th byte. That is the network address, 211.235.128. But we change the subnet mask to /26. Bit 26 is also in the 4th byte, but it's worth only 64. So the next network we will have to add 64 to 128, which gives us 192. So network C's network address will be 211.235.192. Network B has a total of 62 unicast addresses that can be assigned to machines. The address immediately prior to the next network, 211.235.191, is the broadcast address for network B. Now network C, we already added the 64 to the 128 to get to the network address, 211.235.192. Again, we change the subnet mask to /27, and we know that bit number 27 is in the 4th byte, but it's worth only 32. So to the next network address, we have to add 32 to 192. So the next network will be network D at 211.235.224. Network C has a total of 30 unicast addresses, from 211.235.193 to 211.235.222. The address immediately prior to the next network, 211.235.223, is the broadcast address for network C. Now network D, we had added 32 to 192 to arrive at a network address of 211.235.224. We used 30 network bits with a subnet mask of /30. Bit 30 is in the 4th byte, but it's only worth 4. So to get to the next network, we add 4 to 224, so the next network will be at 228. This network only has 2 unicast addresses, 211.235.225 and 211.235.226. The address immediately prior to the next network address, 211.235.227, is the broadcast address for network D. Network E, we had added 4 to 224 to arrive at a network address of 211.235.228. We maintain a subnet mask of /30, meaning bit 30 is again worth 4 in the 4th byte. So to get to the next network, again we will add 4 to 228, so the next network, F, will be at 211.235.232. Again, network E only has 2 unicast addresses, 211.235.229 and 211.235.230. The address immediately prior to the next network, 211.235.231, is the broadcast address for network E. Last but not least, we had added 4 to 228 to arrive at the network address of 211.235.232 for network F. Again, a subnet mask of /30. Bit 30, we know, is 4 in the 4th byte, but this is our last network, so we don't need to increment or add anymore. Again, we have only 2 unicast addresses, 211.235.233 and 211.235.234. The last address, 211.235.235, is the broadcast address for network F. The next network, we would have to add 4 to 232. It would be at 211.235.236, but we don't need it, not for our task. The last step is to apply this now to our network task in the diagram. We have here network A. Network address is 211.235.0/25. Network B, we added 128 to the 4th byte, 211.235.128, but /26. Then network C, we added 64 to the 4th byte, so 211.235.192/27. Then network D, we added 32 to the 4th byte, 211.235.224. /30 is the subnet mask, so therefore to get to network E we add 4 to 224. So network E's network address is 211.235.228. Again, subnet mask /30, so we add 4 to 228 to get to network F, 211.235.232, and a subnet mask of /30, and that is the task at hand.